Good morning. I am K. Palnivel, Assistant Professor of Mathematics, SNS College of Technology, Coimbatore. Today, going to a case study on piecewise regression using cubic spline. Abstract. A watershed erosion reveals spatio-temporal variability and determines sedimentary yield, which is a key to appropriate watershed management, considering several curve numbers as nodal point in the domain. In this paper, we have constructed the approximate curve using cubic splines corresponding to the segment yield index SYI. The aim of this construction is predict SY corresponding to the arbitrary curve numbers lying in the domain of construction. It is observed that cubic spline show a satisfactory performance with NOS efficiency of 61.36%. We have established the quality of approximation by comparing the given value with the approximate value of SY1 at a certain nodal point and noted these values. Quite closed. Next one, introduction. The soil erosion may be defined as the determined and transparent soil, that is the major agent responsible for the erosion in many locations, winds, glaciers, etc. Also the soil erosions. The watershed planning and management highlights the management technique used to control erosion in the catchment watershed area. Due to lack of data availability, estimates are made by means of prediction models that evaluate soil loss or sediment yield separately. Isles proposed an empirical relationship between SYI and area and delivery ratio. A different approach proposed an empirical relationship between delivery ratio and morphological characteristics of catchments such as catchment area, average relief or slope. These models are popularly employed because of their simplicity and easily available data. It is the common experience that the sediment yield largely depends on the rainfall, services of the curve numbers methodology. The larger and CN value will be sediment yield in agricultural watersheds and vice versa. Since Cn represents the runoff producing potential of watershed and Si the potential of sediment yield, it is quite logical and these two parameters which SYA and Cn should exhibit some relationship between them. Study area and data source. Narmada is the largest west flowing river of the Indian peninsula. It is one of the important rivers of India. The Narmada River rises in the Amarkandak Plateau of Maikala range in the Sansod district, Madhya Pradesh at an elevation of 1057 meters above mean sea level at latitudes in 22040 degree north, longitude 81045 inch east. Bagni versus state 2542 kilometers square. The sets are the Madhya Pradesh districts in India. There are the adjacent water sets, the namely Bamni, Manat, Mahmud. The construction together to form an important southern sun-basic destined water. Land use and land cover. Thus, supervised classified location has been used in this study for classification of satellite data. The land use cover classes where agriculture land, fallow, barren, open land, water body, forest areas occupied by each land use were determined. Narmada watershed have a good forest cover and agriculture land, maximum 65.4% areas. Soil map of the study area is generated with the aid of NPSS LUP map. The areas under different soils were identified. After analysis, it was found that area of all watersheds fall under the hydrologic soil group B and hydrologic soil group D, clay soil and loamy soil. to create CN map and hydrologic soil groups in the maps. Digital elevation model, slope map. Digital elevation models were generated from SRTM data. From these maps, slope maps of Narmada watersheds were generated. An investigation of reveals about 95% of the catchment areas watersheds filed the 96.8 and 96.99 under two slope categories, gently and moderately sloping. Finally, going to conclusion, a cubic spline is developed between SYA and CN using 11 subwatershed data. The approximation is validated for sediment yield index for the remaining subwatersheds. Subsequently, the SY data combined watershed exhibit a strong correlation with SYA derived using the cubic spline. The theoretical cubic spline are best approximations of most of practical purposes. In this case study, the authors have verified the computing the cubic splines that the some particular nodal points the actual values of SYA. Hence, we conclude the approximation is acceptable, and the major advantage of the construction lies getting approximate value of SYA every arbitrary nodal point of this one. Thank you. Thank you for watching.